Video notes, here I am. Take your notebook out, let's start the jam. Video notes, here I go. Take your notebook out, let's start the show. Video notes. Video notes. Alright, thanks for tuning in to this week's edition of Video Notes for Mr. Flugum's Physical Science class. We're talking about kinetic molecular theory today. And just so you know, these notes are going to go on page 13 in your science notebook. Alright, so make sure you open it there and let's go ahead and get started. Alright, so kinetic molecular theory. I sometimes just call it kinetic theory for short. Alright, and basically this kind of tells us how matter works. Alright, keep in mind that matter, this idea right here, that is stuff. Alright, everything that takes up space is matter. Okay, alright, so that could be the air around you, it could be the spit in your mouth right now, it could be your parents' car outside. All of that is made of matter. Alright, and kinetic theory helps us understand why some things are solid, some things are liquid, and some things are gas. Okay, so there's three assumptions in kinetic theory. Alright, that's this. Everything is made of small particles, things like atoms and molecules and ions, things that we really can't see. Alright, those particles are always moving, right? And those particles bang into each other, they collide with each other and the other things around them. Now, to understand kinetic molecular theory, we have to understand this idea of temperature. All right? So temperature is a measure of how fast the particles in a substance are moving. Okay? And so when we measure and we get a high temperature, that means those particles are moving around really fast. Okay? When it's colder, those particles slow down. Okay, so there's four different states of matter that we're going to talk about. You've got solids, those tend to have lower temperatures, liquid, gas, and then plasma is the hottest temperatures. Alright, just so you know, plasma, man, that is really hot. That's places like the sun, okay, lightning, and things like that, okay, where there's lots and lots of energy. We'll get into each of these states of matter and what kinetic theory has to tell us about them. Alright, so let's talk about solids. Okay, when you have a solid, the particles are vibrating in place. You may not know it, you may not understand that, but that's what we think. Alright, based on evidence and investigation. Now, those particles are packed tightly together, and because it's in a solid state of matter and fairly cool in temperature for the substance, there's not enough movement for those particles to break away from each other and slip away. Okay? Now when we have a solid, right? A solid is like a block there. The shape and the volume of it, how much space it takes up, do not change. Now when we talk about a liquid, alright, a liquid, there's enough movement in those particles for them to slip out of place, right? And to slide past each other. So here we're at a slightly higher temperature, right? And that temperature depends on the substance, right? Some substances have a very strong attraction between particles. Metals, for example, right? You have to get a metal really hot to get it into a liquid state. Okay? But if you have something like water or nitrogen or something like that, that turns into a liquid at really low temperatures because there isn't much force to hold those particles together. Alright? Can you picture it? If you have like a glass of water and you tip that water back and forth, the water moves, right? Because the shape of water or any liquid changes as the container changes, right? Can you picture those particles sliding past each other? Alright? The one thing about a liquid though is this. Even though the particles are sliding around, the volume stays the same. Alright, a gas. So when we have a gas, we're at a higher temperature, right? That means there's enough energy and movement in those particles that they completely break away from each other and start bouncing around. I always like to envision them as a bunch of super balls bouncing around a room. Alright? and they bounce off each other and they bounce off their container. All right. Now with a gas, there's lots of space in between the particles. And that means this, right? That we not only can we change the shape of a gas by changing the shape of its container, we can also change its volume. We can crunch those particles closer and closer together because there's lots of space in them. That's why we can create pressurized containers, right? Like this here that you might have on a barbecue at home, right? That gas inside there is crunched together so that it's pressurized, so that when we open the valve, it pushes itself out and we can use it. All right, last one here, plasma. You may not have heard much about plasma, but basically it's a fourth state of matter. It's at super high temperatures, right? And in this case, the particles are moving so fast that when they collide with each other, they basically break each other apart. All right? And it kind of becomes this unidentifiable mass of positive and negative charges. Now, when that happens, there's lots of energy given off because it's at such a high temperature. Okay? When you have plasma, you can change the volume and the shape just like you can with a gas, although plasma is a little bit harder to deal with than a gas. All right, well, let's just wrap this up, okay? When we talk about kinetic molecular theory or kinetic theory, that explains how matter behaves, right? Why we have different states of matter, okay? And temperature measures the motion of particles in a substance, right? So as the temperature goes up, the movement of the particles increases, right? And because they move more or less, depending on temperature, that causes things to freeze or melt or boil and go into different states of matter. Well, thanks for tuning in, folks, and I'll see you in class next time. Hope you have a great day.